comes another kind of substituent that is called cyclose. Sorry, I forgot to erase this. Okay, take a look to this. I have a table right here that says formulas of some common cycloalkanes. Now, when you read the word cyclo, we're talking about cyclic shapes. Cyclic shapes are geometrical shapes. Now, where do they come from? Take a look to the ball stick model. Take a look. The ball and stick model represents the carbons, the hydrogens, and the bonds that are between those elements. Remember, in organic chemistry, the base element in organic chemistry is carbon. Now here in this model, carbon is represented by the black balls, okay? So in here, I have 1 carbon, 2, 3 carbons. Because we have 3, the name of that cyclo is going to be cycloprop. Cycloprop, okay? So here I have a mistake. There is, okay now. Now take a look, cycloprop, because prop is the prefix that we use to indicate 3 carbons. Okay, so how do I know this is a cyclo? I mean, if it has only 3 carbons, we can say that it is propane, okay? Because propane has 3 carbons. And they are located in the same position. But why do we say that this is a cyclo? If you notice, between each carbon, I have some sticks. These sticks are bonding the carbons. And if I just take the sticks apart, it's going to form a triangle. And a triangle is a geometric figure. And every geometric figure that you see in organic chemistry will belong to cyclos, okay? If they have only single bonds, they're going to be cycloalkanes. If they have double bonds, they will be cycloalkenes, okay? And if you have a triple bond, it's going to be a cycloalkyne. It's going to depend on the type of bond. But here you notice, okay? Here in these examples, you notice that all the bonds are single. Single bond, single bond, single and single. Take a look. Now, these gray spheres, the gray spheres are hydrogen, the hydrogen atoms, okay? And the black spheres are just carbons. Now, the shape that it is formed when you join these carbons, you will notice that they are geometrical shapes. You have triangle, you have square, you have pentagon, you have hexagon, okay? So they are geometrical shapes, and when this occurs, we are talking about cyclos, okay? Now this is the ball and stick model. We're not going to do these models, but in here you are able to see the carbon attached to every hydrogen, okay? So you will notice that. Now the condensed structural formula is going to represent the same. It's going to join the carbons, but next to each carbon you're going to have the amounts of hydrogens, okay? But as you notice, it's going to have this same shape. You have a triangle here, you have a rectangle or a square over here, okay? You have a pentagon right here, and here you see this hexagon. Okay, so all these shapes are formed, and when you notice that you have a geometric shape, we're going to talk about cyclos. So the reduced formula or the line angle formula is going to be just the geometric shape: triangle, square, pentagon, hexagon, and it continues. If you have 7 carbons, it's going to be a hexagon. If it has 8 carbons, an octagon, 9 carbons, nonagon, and 10 decagon, undecagon, dodecagon. Okay, so it's going to be simple as that, just like we saw in math when you were in 9th grade. Now take a look right. I know I didn't teach you math in 9th grade, but you know, okay? Follow the number and follow the prefix for each number. Now, following these rules, let's start by naming the first example. In the first example, remember, every corner is going to indicate a carbon. So in total, you have 1, 2, 3, 4 carbons. Because it is a geometric figure, you have 4 carbons, okay? And because it is a geometric figure, okay, it is a cyclic figure, you're gonna call it by the name cyclo. Cyclo what? What is the prefix for 4? What is the prefix that we use for 4 carbons? What will be the name? What is going to be the name?
Butane.
Cyclobutane. Okay, very good. Cyclobutane. It ends in ane because they are only single bonds. Remember, whenever you have single bonds, it's going to end in ane because they are alkanes. Let's see this shape. The first thing that you have to do is start counting the carbons. As you notice here, I have 6 carbon. How do you call a 6 carbon geometric figure that has a 6 carbon?
Cycloxane.
Cyclohexane. I mean, just the figure is called hexane, okay? Just the figure is called hexane, but the name of this cycloalkane is going to be the prefix cyclo, and then hexane. Remember the suffix ane, it is because they are only single bonds. Now, if by any chance you had another bond right here, for example, it's not going to be hexane, it's going to be hexene because it's going to be alkene. But in this case, we're not learning about alkenes yet. I'm just telling you that sometimes you will see more than one bond, and this is the way they look like. Sometimes, like in the example C, and I will zoom in the example C and D because they're a little bit more complex. Please focus on this part. In the part C, you know that do you notice that I have this geometric figure, okay? Wait a second because this thing is not updating. Uh, Guys, do you listen to me? Guys, do you listen to me?
Yes.
Okay. Okay, this thing. Wait a second. Okay, guys. I'm sharing the iPad screen because I don't know, it's not updating the app in the computer. I don't know why. Okay, take a look in here. For this particular example, you notice that I have a cyclo right here, but something is external to the cyclo, okay? I have a branch, and you know what happens when we have a branch? We need to name it, we need to include the branch in the name. So the branch or the alkyl that has one carbon is called methyl, okay? But it's not only that. When you have cyclos, you have to number the carbons in the cyclo, okay? And you need to tell the position of the alkyl. In this particular case, it is mandatory, listen to me, it is mandatory that you choose this carbon, the carbon where the branch is attached, that carbon is going to be your position 1, okay? And then you start counting the rest of the carbons because we're talking about a 6 carbon. We're talking about a 6 carbon cyclo, okay? It's going to be the main name is going to be cyclohexane. But I also need to indicate where the methyl is located. My methyl is located in the position 1. So I need to say that I have 1 in the position 1. I have located the branch methyl. So the name of this is going to be 1-methyl cyclohexane. It is easy when you just have one alkyl. It is more complex when you have more alkyls. So take a look to this example. In the example D, you notice that we have a pentagon. Okay? You have a pentagon over there. And you have branches right here, here, and here. This one that has 2 carbons is called ethyl. The one with just 1 carbon is called methyl. And methyl is located twice. Now here, how are we going to start numbering the cyclo? Follow the rule, okay? We need to list the alkyls alphabetically. Now, what alkyl comes first, ethyl or methyl?
Ethyl.
So ethyl is going to come first. The reason is alphabetical order, okay? That's the reason. So because ethyl comes first, that is going to be the first carbon. So this is going to be my first carbon. And you can start numbering the rest of the carbons like this. The red path or the blue path. 1, 2, 3, 4, 5. Okay? You have the 2 paths over there. Now what happens after is that you're going to have the 2 ways to name it. You're going to have the red path and the blue path. So in the red path, you have ethyl located in the position 1. And in the red path also, you're going to have methyl located in the positions 2, 3. And because I have 2 methyls are going to be in the end dimethyl. So if you want to name it by using the red path, it's gonna be 1 ethyl, 2, 3 dimethyl, and then the name of the parent chain, because we have a 5 carbon cyclo, is going to be cyclopentane. That is the red path. But in the blue path, it's going to be slightly different. In the blue path, you're going to have 1 ethyl, okay? And methyl, because it's twice, is going to be dimethyl. And in the blue path, methyls are located in the position 4, 5. So if you have to name it, it's going to be 1 ethyl, 4, 5 dimethyl, and then cyclopentane. Now, when you have the 2 names, they are outside, okay? They are outside. You have to choose what name is better. Remember, we're going to choose the name that has the alkyls listed alphabetically, but also by using the list numbers. So, what path is better, red or blue?
Red. Red.
So the good name for this particular cyclo is going to be 1-ethyl 2,3-dimethyl cyclopentane. The reason is because 1, 2, 3 is less than 1, 4, 5. There are the positions of each color. That's the reason. Okay? Now, you can do it like that or you can do it mentally. I do it here with the procedure step by step, but you can do it mentally. Okay? How I do it mentally? I just see the numbers, okay? In the red position, I see that methyl has 2 and 3. And in the blue position, I see that methyl has the position 4 and 5. So I say it is better for me the red position because I'm going to be using the least numbers. You can do it mentally, okay? You can do it mentally perfectly like that. But here I show you the step-by-step process. I had planned to do this one with you. I didn't have the time mostly because of the that I had to use the iPad, and that took a little more time than expected. But take a look here. You have these branches, okay, and you have this cyclo. So this cyclo has 6 carbons. What is going to be my first carbon? A, B, or C?
E.
It's going to be C. The reason is because this one is ethyl, and ethyl is going to be listed first. So this is going to be the first carbon.